One of the things that's very, very, very important is to be very careful to identify what the question asks for. And going along with that, draw the correct chart. This is going to help guide you through the problem because it's very, very easy to get mixed up. Should I be working with f prime, f double prime, increasing, decreasing, up, down, concave, whatever. Positive, negative, whatever's going on. It's really, really, really easy to get confused, but if you draw out those charts ahead of time, it'll really, really, really help you. It also helps to write what you're looking for at the top. So let's start off with this example. F of x equals 2x to the 4th minus 4x squared plus 3. We're just going to do a whole bunch of different problems with the same equation. The first thing we're looking for is what are the x coordinates of the critical points of f of x. And something that's really, really key here is to remember your vocabulary and just write what are these critical points. So critical points are f prime of x is 0 or undefined. That's the definition that we have. That's what you need to remember. Also notice we're looking for the x coordinates only. So if it's f prime is 0 or undefined, that means that we're coming from the f prime graph and the positive or negative level. We have f of x, we need f prime. So we just take the derivative, bring down the 4, multiply by 2, bring down the 2, and then derivative of 3 is 0. Now we want to figure out simply where this is 0 or undefined. To do that, we have to have that in factored form. Undefined just basically means we're dividing by 0. So factor out an 8x, we've got x squared minus 1. Factor that further. And then let's let any of these equal 0, or if there was something in the denominator, we'd let that equal 0 as well, so because the whole thing would be undefined. So 0 equals 8x, 0 equals x plus 1, or 0 equals x minus 1. X, add 1 to both sides, subtract 1 from both sides, and x equals 0. All that it asks for is where f prime of x is 0 or undefined. So at this point we can stop right there. This has helped guide us into what we're looking at, but we don't need to mark anything on it because it's just asking for this. Where this comes even more in handy is for this next problem, where we say what are the x coordinates of the relative maximum of f of x and so relative maximum, this means f of x changes from increasing to decreasing. That's what the maximum means. So that means we have to have a chart with f of x and increasing, decreasing. Now remember, because we have an equation, we can't find increasing, decreasing, we can only find positive, negative. So if f of x is increasing, decreasing, f prime is the one that's positive, negative. And we just looked up here, we found f prime of x already. And we found our critical points, so we can just mark those right here, -1, 0, and 1. And we have 3 factors. So we can use those 3 factors to figure out where overall the function f prime of x is positive or negative. With a negative number, 8x is going to be negative. -2 plus 1 is going to be negative. -1 minus 1 is negative. 3 negatives give us a negative overall. Between 0 and 1, -1/2 would give us a negative. -1/2 plus 1 would be positive. And then negative again, positive overall. 1/2, that would give us a positive here. Positive here. 1/2 minus 1 is still negative. And then greater than 1, that would be positive. Positive. 2 minus 1, still positive. So there we have for f prime. We're going to translate that back up into f of x. That's decreasing, increasing, decreasing, increasing. Now we're looking for the relative maximum. So that's not the absolute maximum, where we would look at all 3 of these points, where f of x starts decreasing or stops increasing. The relative maximum only happens when we have this change from increasing to decreasing. So only right there. We're asked for the x-coordinates. So the x-coordinate of the relative maximum of f of x is x equals 0 because f prime of x changes from positive to negative, meaning f of x changes from increasing to decreasing. Okay. So continuing on, we could also be asked, what is the absolute maximum of f of x on the interval -2 to 2. So here the absolute maximums, we're looking for the highest value for f of x. And we're looking for f of x, the absolute maximum, that's increasing, decreasing. And we already have the increasing, decreasing chart from right up here, so we can actually just copy that right over. Now notice that this is not asking for relative maximum, but rather absolute maximum. So in this case, we look at all of the places where f of x starts decreasing or stops increasing. So relative minimum, just where it switches. Absolute, or excuse me, relative maximum, just where it switches. Absolute, we're looking at the endpoints as well. So that means that the potential values are, and let's see, we stopped at -2, we stopped at 2, x equals -2, x equals 0, or x equals 2. And now we need to check these to see which one actually produces the highest value. So f of -2, remember this is f, so we're going to go all the way back up to our f equation. This one, don't put it back into f prime because it's saying f of -2. That's 2 times -2 to the 4th minus 4 times -2 squared plus 3. So f of -2 equals 2 times 16 minus 4 times 4 plus 3, f of negative 2 equals 32 minus 16 plus 3, f of negative 2. When we subtract and add that, we should get 19. So there's one of them. Now we'll do f of 0. 2 times 0 to the 4th minus 4 times 0 squared plus 3. Gotta love those zeros. Those terms drop out immediately. F of 0 equals 3. And then our final one is that f of 2. My bad, I copied the problem wrong down. I meant to have this be 3 instead of 2. Okay, f of 3, so we're going to put in 2 times 3 to the 4th minus 4 times 3 squared plus 3. It's 2 times 81 minus 4 times 9 plus 3. 162 minus 36 plus 3. That's all going to give us 129. Clearly, this one is the highest one. So we would say the absolute maximum of f of x on the interval negative 2 to 3 is 129. This occurs when x equals 3 because f of 3 is greater than f of 0 and f of 3 is greater than f of negative 2, and all other values are less than these. With this same equation, we can also ask yet another question. This is D. What are the x coordinates of any inflection points of f of x? Remember, inflection points mean f of x changes concavity. So the line I'm going to draw is going to be f of x, and it's going to be the concave up, concave down one. I've got to translate that into positive, negative. Concavity in f double prime is positive, negative. So that means I need the equation for f double prime. So if I look back here, I'd gotten f of x, I'd gotten f prime, so let's just write those out again. F of x is 2x to the 4th minus 4x squared plus 3, and I'd found that f prime was 8x cubed minus 8x. So one more time, f double prime of x, I'm going to bring down that 3, 8 times 3 is 24x squared minus 8. And then I need that in factored form as always, so f double prime of x, I'm going to factor out that 8. Got 3x squared minus 1. And so we're in a situation where either 0 equals 8, which is never true, or 3x squared minus 1 equals 0. Add 1 to both sides, divide by 3, and take plus or minus the square root. This gives me my numbers to put here. And now I've got the two factors. 8 is always going to be positive. 3 3x minus 1 is a little trickier. So if we've got a very negative number like negative 10 squared is positive, times 3 is a positive, minus 1, that's just a little minus, so it's going to be positive overall. In between, let's say 0. 0 squared times 3 is 0, minus 1 is a negative. And if we have a number over here, let's say 10. 10 squared times 3 is positive, minus 1, still positive. So that gives us concave up, concave down, and concave up. So our inflection points are where f of x changes concavity. So the inflection points of f of x are at x equals negative square root of 1/3 and x equals positive square root of 1/3 because f double prime of x changes sign. So f of x changes concavity. We can also be asked simply about increasing, decreasing, or concave up, concave down. So let's say for what values of x is f of x decreasing. So decreasing is obviously the increasing, decreasing line for f of x. And over on previous pages, we already created that line based on f prime of x. So just recopying that, that was negative 1, 0, 1. It was decreasing, increasing, decreasing, increasing. And so we can see that f of x is decreasing when x is less than negative 1 or x is between 0 and 1. Because, and how we knew that when we're looking right here, was that f prime of x was negative. And there we go. Similarly, we could ask for what values of x is f of x concave down. That's clearly an f of x, and concave down comes from concave up and down. And we just found that in a previous problem. So here this is negative root 1/3. This is positive root 1/3, and it was concave up, concave down, concave up. So we can say f of x is concave down when x is between negative root 1/3 and positive root 1/3, because, remember how we figured that out, f double prime of x is negative. We can also be asked to find something on a very specific domain. So let's do this one. How about what is the relative minimum? Actually, let's say what is the x-coordinate of the relative minimum on the interval x is greater than 0. Okay, well, let's go back to the last f of x increasing, decreasing line that we had. So that's this one right here. We only want when x is greater than 0, so I'm going to cut it off right here. Go that way. That's 1, decreasing, increasing. So here we can clearly see that the relative minimum right here because f prime of x changes from negative, that's the translation, to positive, meaning f of x changes from decreasing to increasing.